After asset information is fetched from our configured adapters, we can browse to the devices page and view details about each asset and the total number of assets retrieved between all of the configured adapters. The Axonius platform takes care of normalization and de-duplication, leaving us with a unique number of devices. In my environment, I have 40,363 unique devices. In the table, we can view the asset attributes returned from each adapter along with the normalized attributes that Axonius has calculated. Let's begin with the adapter connections column. This column presents which adapters returned data on this asset. With the expansion of this column, you can quickly determine which solutions are returning inconsistent data or have gone a while without seeing a specific device. The first entry in my table has 8 adapters that are associated with it. Each of these adapters may return different information, and the information from each adapter can be displayed in columns within our table. We can click on Edit Columns to modify which columns are displayed and the column order. The available columns we're viewing by default are the Axonius aggregated columns. By selecting the dropdown, we can also select columns specific to our configured adapters. Let's begin by adding the Axonius aggregated software name and software version as columns to our table. If we'd like, we can also change the displayed column order by dragging and dropping columns to the order of our liking. To avoid adding and re-adding columns constantly, you can also save the column display as the user default. To revert back to columns at any point, you can click on Edit Columns and reset columns to user or system default. To view more information on this asset, we can click into the row and we'll be navigated to the device profile page. This view provides information on the data returned by each of our adapter connections. At the top, Axonius will present common fields. The fields displayed here are common amongst many adapters. For example, hostname, network interfaces, and fetch time are fields that many adapters will often return. By scrolling through the results, we'll reach a specific field section. This section contains fields that are adapter specific. To get a more complete picture of what information the solution returned via the API, we can select View Advanced. This view displays a formatted, collapsible view of the API response. If we'd like to view the raw response in a JSON string, we can also select View JSON to see the entire response without formatting. Clicking View Basic will take you back to the default view. By selecting Custom Data under the Adapter Connections tab, we can view and manage custom fields associated with this device. By clicking Manage Custom Fields, you can select an existing or new field to add custom data to. We'll add a custom field for desktop and make it a Boolean field and set the value as true. Next, let's review the Aggregated tab. This view displays Axonius aggregated fields, which have been normalized automatically when comparing the similarities and differences between the data returned from our configured adapters. Axonius takes into account the last fetch time, number of occurrences of a value, along with other key details to calculate what should be displayed to the user. If you scroll to the bottom, you'll notice a section for preferred fields. If populated, we'd recommend using these fields as the source of truth. Behind the scenes, the preferred fields are attempting to display information based on the quality of the source. In many situations, an endpoint detection and response solution will have a more accurate representation of a device's host name than a vulnerability scanner. That's just one example of many that Axonius takes into account when calculating a preferred field. The Aggregated tab also contains more detailed information about the selected asset. This tab displays open ports, network interfaces, installed software, security patches, agent versions, and hard drives. The type of device and the connected adapters dictates which tabs will be displayed on the left. The context of each selected tab can be exported as a CSV. Moving to enforcement tasks. This tab displays details on enforcements that were executed that include the selected asset. If you'd like to see more details on this enforcement task, you can select the task name in each row. We'll cover more details about enforcements later in this course. The next tab is Notes. Users have the ability to view and submit multiple note entries for each device. The final tab is Tags. This tab will display the tags associated with this device. Tags can also be set with an expiration date, which will also be displayed in this tab if they're set. If you'd like to add or remove a tag, you can click on Edit Tags. The next area to highlight are queries. When searching for asset information, the best place to start is with the query wizard. The query wizard is a filter that is composed of the following elements: a where and where not switch. If there's two or more rows in a query, then similarly, there will also be an or, an and not, or an or not switch for all rows to and after. The query wizard also includes a not flag, a source dropdown, adapter dropdown, field dropdown, operator dropdown, a value field, and bracket controls. We'll go over examples of using each component of the query wizard. Let's begin by clearing the wizard and recreating the query shown step by step. In this query, I'd like to display all Windows devices that have not been observed by Active Directory. There are multiple ways to create this query, and I'd recommend to start by using Axonius Aggregated Fields as the source. We're going to take advantage of the details that Axonius pulled in from multiple adapters and display unique devices that are running Windows. To do this, we can set Axonius as our adapter dropdown and specify OS type in our field dropdown. When getting started and learning more about aggregated fields, I'd recommend searching based off of keyword for the details you're looking for. For example, if you're hoping to identify public network interfaces, start by typing in public in the field dropdown. Next, we select our operator. In this case, we're looking for Windows devices. The best choice in this scenario is the operator equals. If you visit docs.axonius.com and search for Query Wizard, there's a great detailed example of which field types support each operator. The last step for our first expression is to select Windows as our value. To complete our query, we'll need to add an additional filter expression. To add a new row, click on the plus symbol. We're building our query to return Windows devices that are not seen by Active Directory. We'll start by selecting the not flag on our second expression and changing the adapter to Microsoft Active Directory. We'll leave ID as our field selection and select exists as our operator. As we add in filter expressions into the query wizard, the table will update with the amount of devices matching the query. It's possible that devices matching this query are violating your IT or security policy. Since policies are dynamic and often comprised of use cases, it would be recommended to save queries that can be used in multiple places and combine saved queries as necessary. To save a query, click on Save As next to New Query. Saved queries must have a name. The description and tags are optional. Both are recommended and excellent strategies for supplying team members with the context to easily find and learn more about the query. Axonius also provides an option to save the query as private, which would make this saved query only visible and usable to your user. Now let's go through another similar example. As part of our IT and security policy, our organization has created a requirement to identify devices that have a Windows operating system and are not part of an Active Directory domain. We can construct a similar query that returns devices that have an OS type equal to Windows, a Microsoft Active Directory ID, and that are not part of a domain. At this moment in time, there are not any devices violating this part of our policy. As time goes on, this is subject to change, so we'll want to click on Save As and provide the query with a name at a minimum. Now let's begin to build a query that can be as dynamic as our policies and provide insight about our assets. In this query, we'll select Saved Queries as the field and select our first saved query as the value. In the query wizard, you can select Duplicate Row to make a copy of the first row expression. In the second row, we'll change the value to be our second saved query. Axonius enables users to quickly and easily perform new searches based on saved searches. In Axonius, if we make any changes to our first saved query, the query that we're building will not need to be updated since it's pointing to another query. In some situations, it will be helpful to use brackets to separate parts of a query. By using brackets around the start and end of a query, I can quickly search for the inverse of this filter by selecting the where switch and changing it to where not. Lastly, let's save this query by giving it a name and providing a description and a tag. There's a few other aspects of filters to cover. A common use case is searching for devices that have a specific software version. This is often used to find out-of-date software that can cause vulnerabilities or to uncover unwanted software that is installed on devices. For our use case, we'd like to find devices that have an outdated version of Chrome. The typical flow for performing a search would be to add filters for the software name and software version. There's also an Axonius field for software name and version combined. In any case, using the aggregated data will not exactly answer the question. This is because the filter is searching for assets that have Google Chrome installed and have an application version less than 80. Now, let's examine this filter a bit more closely. We're searching for software name equals Chrome and software version less than 80. Some devices may have Google Chrome installed and another application that has a version number less than 80. We could use the software name and version field and use regex as an operator to satisfy our filter. More importantly though, our goal is to enable our organization, and part of that involves creating queries that can be maintained and digested by other users. A better way to create this filter is to select the source dropdown and switch to complex field. Let's start by viewing the available fields when switching to the complex field as the source. A few examples here are open ports, network interfaces, and installed software. These fields are also asset information that we observed in the device profile page. If we click into a device in the table, we can navigate to the Aggregated tab and click Installed Software. The details in each tab can be used as a filter in a complex field expression. Think of the information in this table as an object with key value pairs. Software name and version are keys, and Chrome, along with the version of Chrome, are the values. Going back to the query wizard, we'll specify this in our query filter. After adding in the remaining logic, let's save our query filter. Let's review another source in the query wizard, field comparisons. To compare the values of two fields, we can select field comparison from the source dropdown. In this use case, we'll be searching for data inconsistencies between two adapters and would like to know which devices returned from Cisco Meraki and VMware do not have the same hostname. By selecting Cisco Meraki as our first adapter and hostname as the field, and selecting VMware as our second adapter, and again using hostname as the field, Axonius will display which devices share an exact match on the hostname. Our use case is to view the inverse of this filter. To view the inverse, we can select the not flag. Let's also take a moment to save this query filter. There is an additional source that can be selected in the source dropdown, and that's asset entity. In some situations, a single adapter will return multiple entries for a single device. An example of this would be a network scanning solution or vulnerability scanner that observes a device via multiple network interfaces. Axonius takes a lot of the heavy lifting off of our hands by normalizing and deduplicating information. For this use case, our goal is to identify the nature in which duplicate devices are being observed by Cisco Meraki. From the last search, I noticed that there were some entries that were seen in the last day and others that were seen more than 2 days ago. The goal is to search for devices that were seen in the last day and weren't seen in the last 2 days. If I were to create 2 expressions with Meraki as the adapter and last days as the field, I can attempt to create the query using the aggregated source type. Without a special way to ask this question, this query would naturally not return any results. The solution in Axonius is to select asset entity as the source for the second expression. By selecting Cisco Meraki as the source and last days as the operator, I can set the expression to search for devices returned by this adapter that has multiple entries that weren't seen in the last 2 days. Be sure to select the not flag within the entity expression and not outside of it. By expanding the adapter connections column, we now have more insight as to why this adapter may consider this asset as 2 separate devices. It looks like this device has multiple network interfaces, which can be causing some confusion if the solution is passively scanning our network. Let's again take a moment to save this query filter. The search bar at the top can also be used to search for assets. By typing in text and hitting enter, we're performing a case-sensitive exact match search on the fields stored within Axonius. For example, by typing in the name of a user that has an account on a device, we can return results as long as there is an exact match. To perform a case-insensitive search, you can select the search dropdown, select a field, and provide input. Now let's take a moment to go back to the devices page and review how we can export and perform actions on the returned devices. If you'd like to export a CSV of the devices table, be sure to edit the columns that you'd like to present in the CSV and then click Export CSV. While exporting data, you can specify a file name split by asset entities or field values. You can specify a delimiter to use for multi-value fields, and you can specify the maximum number of rows. Then hit export. To perform a single or bulk action on devices within the table, you can start by selecting the devices of interest, clicking on actions, and performing an action. Just a few examples of the actions that you can perform are adding tags, linking and unlinking devices, creating an enforcement, deleting devices, filtering out query results, and adding custom fields. There's a few points to mention on deleting and linking and unlinking devices. If a device is deleted, it may be added again to Axonius if it's discovered in a future discovery cycle through an adapter. Linking a device manually correlates at least 2 device records together and consolidates their details into a single device. Keep in mind that manual linkage cannot be reverted and it will not be overridden on the next correlation. Unlinking breaks the correlation between an adapter source and a device and breaks it into separate devices. For example, if a device has been correlated from 3 different adapters, unlinking that device will result in 3 different unlinked devices. Also keep in mind, any manually unlinked devices may be relinked the next time that Axonius correlates device data. At this point, we've created and saved several queries. To view, manage, and delete saved queries, click on the Saved Queries page. When navigated to this page, we can search for our saved queries based off of query name, tags, access, and the date the query was last executed. The table is also very helpful for identifying attributes about our saved queries. For example, by using the used in and last used columns, we can observe which dashboards, reports, and enforcements a query has been used in, and if there are queries that have been saved but never actually used. By clicking on a saved query, Axonius presents the standalone query builder. From this builder, we can edit a query, we can copy a query link, create a new enforcement from this query. We can also duplicate this query and delete this saved query. Another great feature to mention about the saved queries page is the ability to run queries directly from this query builder. If, for example, we needed to remove a tag and add a filter expression to our saved query, we can click on Edit. And from here, we can add additional tags and modify the query as needed. One piece to keep in mind is public queries cannot be converted into private queries from this page. The best path would be to duplicate this query and make the new query private. It is possible to make a private query public. From the query builder, we can click on the eye icon to set this query as public. By setting this query as public, we'll be able to use the query in enforcements and dashboards that are accessible by all users. By selecting a single or multiple saved queries in the saved queries table, we can select actions to add tags to the selected saved queries or delete the saved queries that we have selected. Axonius also provides the ability to view the history of saved and unsaved queries. We can view the query history by navigating to the Saved Queries page and then selecting Query History. We can filter this table by the query name, the user that executed the query, tags, and also the date the query was executed. By selecting any row in the Query History table, we can choose to rerun a query and compare the number of results returned.